All right, let's talk about generative AI. We're going to dive deep and really try to crack open this fascinating and honestly pretty misunderstood world. Today, we are going to peek inside that black box and really get a feel for how these incredible tools actually, well, think.
And this isn't just hype. Leaders across literally every industry are seeing the potential here. I think Satya Nadella from Microsoft just nailed it with this quote. AI isn't just another gadget. It is a fundamental shift, and it has the power to help us tackle some of the biggest challenges we face as a species.
And look, this isn't some sci-fi far-off future we're talking about. I mean, think about it. In just a handful of years, AI has completely exploded out of the research labs and woven itself right into our daily lives. It's on our phones, it's in the tools we use for work, it's everywhere.
Okay, so here's our game plan. We're going to start with the sheer scale of this AI explosion. Then we'll clear up why AI is not just a glorified search engine. After that, we'll take that peek inside the black box. We'll cover how an AI actually learns, we'll get into the weeds on why they sometimes hallucinate, and we'll wrap up by looking at what might be coming next.
So, first up, the AI explosion. And if you want to understand what's happening, you have to wrap your head around one thing. Just the absolutely mind-boggling scale of it all.
So what does that scale actually look like in practice? Take a look at this number. 15 trillion. That's how many tokens Meta's Llama 3 model was trained on. And a token is just a little piece of text, could be a word or even part of a word. So 15 trillion of them. To give you some perspective, GPT-3, the model that really kicked off this whole revolution, was trained on a tiny fraction of that. It's just an astronomical leap in the amount of information these things are learning from.
And all that data, all those tokens, they feed what we call a large language model, or an LLM. Now, the definition here says it's an AI trained on vast text data. But what that really means is that it has analyzed trillions of sentences to build its own internal map of how language actually works. And that's what lets it not just understand what we're saying, but to generate and play with language in a way that feels incredibly, well, okay, this brings us to a really crucial point, and it's probably one of the biggest misconceptions about this tech. An LLM might feel like a super-powered search engine, but under the hood, it operates in a fundamentally different way. It's a whole new way of thinking. So think of it this way. A search engine is like a librarian. You ask a question, and it goes and finds an existing book or document from a massive index. It retrieves information. But an LLM doesn't find anything. It creates answers from scratch. It's a probability machine, and it's constantly asking itself just one simple question. Based on everything I've ever read, what is the most statistically likely word to come next? So if it's just a probability machine playing a word game, how does it get so good at it? Let's peel back the layers and finally get inside that famous black box to look at the basic building blocks. The first, most obvious question is, what are these models even made of, right? What are the fundamental parts that make the whole thing tick? Okay, the first building block you need to know about is something called parameters. The absolute best way to think about these is like the artificial neurons in the AI's brain. In reality, they're just a massive number of variables. We're talking millions, sometimes billions of them, that the model tweaks and adjusts over and over and over again during training. And these little adjustments are how it captures all the patterns and knowledge from the data it's fed. The second building block is the token. We mentioned this before. This is the basic unit of text that the model actually sees and processes. It's not always a full word. It could be a prefix like re or a suffix like ing, or just a single comma. And as we saw, the number of these that the models are learning from has just skyrocketed from billions into the trillions. So we've got the building blocks, parameters, and tokens. Now let's look at the actual process. How does an AI take all this data and actually learn from it? And then how does it use that knowledge to answer your questions? So the process usually breaks down into 4 main steps. First, you have to collect a mind-boggling amount of data: books, websites, articles, the whole shebang. Then the model chews through all of it, adjusting those parameters to learn the patterns. After that big learning phase, it's often fine-tuned for specific jobs. And finally, it gets tested like crazy to see how accurate and reliable it is. Now, this whole learning process is really broken into 2 totally separate phases. The first is training. You can think of this as the AI going to school. And just like a long, expensive education, it is incredibly slow and costs a fortune. We're talking months of time and millions of dollars. The second phase is inference. This is like exam day. It happens almost instantly, right when you type in a prompt. It's super fast, super cheap, and it's where the model actually uses everything it learned to give you an answer. All right, now for the topic that everybody's talking about, hallucinations. Why do these incredibly smart models sometimes just make stuff up? Well, it all boils down to this constant tug of war between creativity and confusion. Remember what we said, it is all a probability game. An AI is not looking things up in a factual database. It is always just predicting the next most likely token to continue the sentence. Sometimes that leads to some amazing creative insights. And other times, well, it leads to confidently stated nonsense. And here is the really fascinating part. Developers can actually control this behavior. They use a setting called temperature to dial the randomness of the AI's output up or down. You can literally think of it as a creativity knob. A low temperature makes the model more focused, more factual, sticking to the safest, most likely answers. But if you crank that temperature up, you're encouraging it to take more risks and be a lot more creative. This chart shows you exactly how that works. Over on the left, with a low temperature, you see the probability is stacked super high on one single most likely word. The AI is almost always going to pick that word, giving you a very predictable answer. But on the right, when you turn up the heat, that probability gets spread out across a whole bunch of different words. The AI might pick a less obvious, more surprising option, and that can lead to a really creative answer, or sometimes a completely wrong, hallucinated one. So where is all this headed? I mean, the pace of change right now is just staggering. So let's take a look at what might come next, both the incredible predictions and the very, very real problems that we need to solve. Some of the predictions from experts in the field are pretty wild. Some believe that by 2026, that's just a couple of years away, artificial general intelligence, or AGI, becomes more likely than not. By 2028, AI could be automating its own research and development. And by 2029, it could outperform humans in almost all intellectual work. The speed of this is just hard to comprehend. But let's be clear, it is not all smooth sailing. There are enormous challenges we have to figure out. How do we deal with bias? What about data privacy? These models take a shocking amount of energy to build and run. And we still have a huge problem with interpretability, that black box problem we've been talking about, of not fully knowing why they make the choices they do. And that brings us to our final thought for today, which is inspired by the philosopher David Chalmers. We know one thing for sure. The human brain, this 3-pound machine made of meat, somehow produces consciousness. So as these artificial brains, these neural networks, become exponentially more complex, the real question we're left with isn't if a machine can be conscious, but whether these very machines we're building right now are on a path to developing it too.